Assalamualaikum. In this video, our group will present about our topic, which is linear prediction. First of all, this video was prepared by Adit Zumaziad, Abdullah Muhammad, Muhammad Yahya, and Aiman Hakim. So, what exactly is linear prediction? Before we get into the meaning and how it works, we should first define machine learning. Machine learning is a subfield of artificial intelligence AI. The goal of machine learning generally is to understand the structure of data and fit that data into models that can be understood and utilized by people. Any technology used today has benefited from machine learning. Facial recognition technology allows social media platforms to help users tag and share photos of friends. Optical character recognition, which is OCR, is technology that converts image of text into movable type. Recommendation engine powered by machine learning suggests what movies or television show to watch next based on user preference. Self-driving cars can rely on machine learning to navigate may soon be available to consumers. Machine learning is a continuously developing field. Because of this, there are some considerations to keep in mind as you work with machine learning methodologies or analyze the impact of machine learning processes. Now, what is linear prediction? When evaluating time series data, linear prediction can be used to anticipate future values. To estimate future values of a signal in terms of linear function of previous samples, it is commonly employed for digital signal processing. A discrete time signal future values can be predicted mathematically using a linear function of the signal's past values. Linear prediction is sometimes referred to as a linear predictive coding, which is LPC, in digital signal processing and can be considered a subset of filter theory. Mathematically, modeling and optimization are both included in the topic of system analysis, which is a subset of mathematics. To be clear, we also provide an example of a real-world use of machine learning here. Linear regression is frequently used by medical researchers to better understand the connection between a patient's blood pressure and the dosage of a medicine. Researchers may, for example, offer different doses of a medicine to patients and monitor how their blood pressure responds to the treatment. They might use dose as a predictor and blood pressure as a response variable in a simple linear regression model. The following would be the regression model. Okay, blood pressure equal to the beta 0 plus beta 1, which is a dosage. The coefficient beta 0 would represent the expected blood pressure when dosage is 0. The coefficient beta 1 would represent the average change in blood pressure when dosage is increased by 1 unit. If beta 1 is negative, it will mean that an increase in dosage is associated with a decrease in blood pressure. If beta 1 is close to 0, it will mean that an increase in dosage is associated with no change in blood pressure. If beta 1 is positive, it would mean that an increase in dosage is associated with an increase in blood pressure. Depending on the value of beta 1, researchers may decide to change the dosage given to the patient.
There are a total of 5 types of regression. The first one is lasso regression, the second one is brief regression, the third one is polynomial regression, the fourth one is logistic regression, and the final one is linear regression. First, I'm going to talk about linear regression. Okay, it is the most common machine learning regression model, and it is often used as a linear approach for modeling the relationship between a scalar response and one or more experimental variables. Besides that, you can also estimate the relationship between one independent variable and one dependent variable using a straight line. And when there is a linear relationship between the variable, linear regression should be used. But however, because of the model's vulnerability to outliers, the more data that there is, the greater the likelihood that the incorrect predictions will be made. Okay, next I'm going to talk about logistic regression. Logistic regression is a statistical analysis method to predict a binary outcome, such as a yes or no, based on prior observation of a dataset. There are three types of logistic regression that includes binary, multinomial, and ordinal. And in the logistic regression, the CMOD function is utilized to show how the target and the independent variables are related. There are a few of consideration to make when implementing a logistic regression. There should be no high correlation between the independent variables in a live data set for this method to operate. After this, I'm going to talk about polynomial regression. Polynomial regression is a form of linear regression known as a special case of multiple linear regression, which estimates the relationship as a 9-degree polynomial. Okay, polynomial regression is often used to obtain the best result, and it also provides a great relationship between the independent and dependent variables. Okay, after that is risk regression. Risk regression is a model tuning method that is used to analyze any data that suffers from multicollinearity, and this method performs L2 regularization. The risk regression penalty, which introduces a modest amount of bias, makes this risk regression sensitive to overfitting. And lastly, the performance of risk regression is good when there is a subset of two coefficients which are small or even zero. Next, I'm going to talk about lasso regression. The lasso regression is a type of linear regression that uses shrinkage. Shrinkage is where data values are shrunk to its center point, like the mean. And the lasso procedure also encourages simple sparse models, in essence models with fewer parameters. And regression techniques like lasso and risk regression are both utilized to reduce the model's complexity by making the coefficient values close to zero, which does not happen in the case of risk regression, but it does so in order to avoid overfitting. Okay, for data that can be divided into linear segments, the linear regression performs extraordinarily well, and linear regression, it is easier to deploy, understand, and train with, and by using dimensional reduction, regression, and cross-validation, it tackles the overfitting issues fairly effectively, and extrapolation from a single dataset is an additional approach. Okay. On the other hand, this is the disadvantage of linear regression. Okay, assumption that dependent and independent variables follows a straight line and noise and overfittings, like mentioned before, are common problems. Outliers have high impact on the results of linear regression, and multicollinearity is a possible outcome. Okay, this is the conclusion of linear prediction machine learning. So linear prediction, it proves that it has a lot of benefits, and the pros of when using linear prediction, it outweighs the cons. Moreover, regression should only be used where it is appropriate and where there is sufficient quantity and quality of data to give the analysis meaning beyond your sample.